determinants. Now we're going to talk the inverses. Now, this video specifically is how to find the inverse of a 2x2 matrix. Now, there are other videos. There's going to be another video for a 3x3 matrix, and then 4x4, like I said, is calculate the time. However, now, this video specifically is how to find the inverse of the matrix. Now, there's another video about how to use the inverse of a matrix, because we use the inverse of matrices to kind of solve matrix equations. Now, that's a whole video in itself. This video specifically is how to find the inverse of any 2x2 matrix. We'll talk about how and why we use the inverses. We'll talk about how and why we use the inverses of matrices later. This is how to find it. First off, notation. The inverse of a matrix A looks like this. A to the negative 1 power. Exactly right. That's how you know that you're either looking at an inverse or that they're asking you to find an inverse. All right, so let's get to it. Here we are. Here's our 2x2 original matrix A. Here's our inverse matrix, A to the negative 1 power. Couple of things you gotta do. First thing to do when finding the inverse of a 2x2 matrix is you gotta find the determinant of your original matrix A. So you're gonna find the determinant of A because you're gonna use that in your inverse. As a matter of fact, we need it to, yeah, exactly right. We have to multiply everything in the matrix by the reciprocal of the determinant. So it's another way of saying divide every number in my new matrix by the old determinant. All right, next step. Next thing I do, switch the places of A and D. This number or value that used to be top left corner and this number or value that used to be bottom right, they get switched. Just like that. And then the last and final step, I'm going to change the signs on B and C. If it was a negative before, it'll be positive now. If it was a positive before, it's going to be negative now. So I switch the places of A and D, change the signs on B and C. It's going to look like this. Bang! Exactly right. And that's how we get an inverse matrix. I know it'll look better than an example. Let's do an example. Bang! Here's a matrix A. Let's see if we can't find the inverse. First thing we gotta do is find the determinant. Remember how to find the determinant? Bang! Exactly right. Diagonal 1, negative 1 times 0 minus diagonal 2, 3 times 4. What is negative 1 times 0 minus 3 times 4? Negative 12, exactly right. Now, I'm going to go about this one of two ways. Now, I'm going to multiply all of those things by 1 over negative 12 or divide each one by negative 12. So let's do what we do. Ready? I got to now switch the places of A and D. Take these two things, switch their places. Yeah, exactly right. And now I'm going to take these two and switch their signs. Bang! Exactly right. Now let's clean up a little bit. I don't really like to leave this outside. I mean, you can, but let's just go ahead and multiply everything in there times that 1 over 12. Which in fact, we're really just, exactly right, dividing everything by negative 12. Let's clean up, reduce, and get our final answer. Bang! And we have our inverse. Well done, well done. Let me show you one more. Yeah, all the way up. So let's do it. Let's find the inverse of this matrix right here. Remember what the first step was? Yeah, determinant. Exactly right. Let's clean this up a little bit. We know what x times 2 is. Yeah, negative 1 times negative 1 is positive 1, but I'm subtracting. So bang. You know why we need that? Because it goes right there. Exactly right. Exactly right. We're done with the hard part. Let's get to the easy stuff. Switch places. Switch signs. Bang! Done. Now, in a situation like this where you have a variable in your denominator here, you can totally leave your answer like that. Now, if you do want to perform this multiplication and go ahead, well, division, multiplication, how you look at it, you can divide each one of those entries by this, and it'll look something like this. Exactly right. I am, and most math teachers will be okay with either one of these. Save yourself a little bit of work. Thanks a lot, man. More to come. Oh yeah.